Today what we're going to do is we're going to do a couple more examples of graphing functions, okay? So the first one we're going to do, this is continuing on, so this is number 4. Okay, example 4. So what we're going to do is we're going to graph the function y equals 1/2 x plus 1 for the domain all real numbers. Now, if we're using the domain all real numbers, I get to pick any numbers I want, right? So if I'm picking any numbers I want, we talked about yesterday how normally I pick the numbers -2, -1, 0, 1, and 2. Okay? That's normally what I do. However, sometimes if there's a good reason to pick different numbers, I will pick different numbers than what I normally pick. So in this case, this is a good reason. Do you guys see this fraction here? Okay. What's going to happen when I multiply this fraction by an odd number, like 1?
It's going to become a decimal.
Yeah, it stays a fraction, or we can either convert it to a decimal, right? Which seems like kind of a pain in the butt. I don't want to do that. Okay? I would rather multiply it by a number that I know is going to make it turn into not a fraction anymore. Okay? So, numbers that I can multiply this by that will make it turn into not a fraction would be any numbers that are numbers counting by the denominator. Okay? The denominator is 2. So what are counting by 2 numbers? 2, 4, 6, 8. Also, I could use negative counting by 2 numbers, right? Also, I could use 0, because what's 0 times anything? 0. That makes it not a fraction anymore either. Okay? So, when I pick my numbers today, I'm not going to pick the normal ones that I use. I'm going to pick -4, -2, 0, +2, +4. I like those numbers better. Okay? Now, here's my function I'm working with, 1/2 x plus 1. Today, this one has a y, so I'm going to make it a y here. And then this ordered pair is going to be x comma y, since there was a y in this one today. Okay? All right, so now let's go ahead and start evaluating my function. So I have 1/2 times -4 plus 1. Okay, so what happens here when I reduce on the diagonal? What's -4 and 2 when I reduce them? What can I reduce them by? 2. So I get -2 plus 1. Is everyone understanding how I got from this, changing this thing into -2? You can also think of it this way. Multiply the top. What's -4 times 1? -4. What's -4 divided by 2? -2. Okay? So, that's getting rid of my fraction there. Now I just finished this addition. It's really -1. So here's my first ordered pair. -4, -1. Yes. Okay? All right, so now let's do the second one. 1/2 times -2 plus 1. So this makes a total of -1 plus 1. Okay, so what is -1 plus 1? 0. Okay, so my next ordered pair is -2, 0. Okay, now we're going to do the fraction 1/2 times 0. Well, what's anything times 0? 0. So this whole thing makes 0 plus 1. So we get 1. Okay, next we're going to do 1/2 times +2. So what is 1/2 times +2? 1. 1 plus 1? 2. Okay, and for my last number, 1/2 times 4 plus 1. What's 4 times 1/2?
2.
Yeah, well, you can do 4 times 1 and then divide by 2, so that gives you 2. Or you can reduce on the diagonal, and that gives you 2 also, right? So now 2 plus 1 is 3. Okay, now you're going to take, if you saved your last graph, you're going to take it and you're going to glue it in. Can you send one person from your group to go get glue and scissors from up front so that you can glue your graph in? Okay, so let's check if you guys got your graph right. You should have had -4, -1 for your first point, then -2, 0, which was right here on the line, 0, 1, which was up here, 1, what was it? Sorry, 2, 2, 2, 2, right here, and then 4, 3. Okay, class, do I get to connect these?
No.
What is my domain? All real numbers. So if my domain is all real numbers, what does that mean? It means that my domain is all x values. So that means that it's all the x values in between these points and continuing past these points. Okay? So I am going to connect and I'm going to draw arrows on the end of my line showing that the domain continues to all values. Okay? All right. Are there questions as to why we're getting to connect that one? Okay. Do we need more time there? Okay, here's your next problem. Everyone's going to draw a graph for this one. Unless you have a graph left. I didn't think you guys had one left. Okay, write it down, please. Okay, on this one, we're going to graph it for the domain. This is your domain here. Okay, so if they've given us this domain, that means that I have to use those numbers, and those are the only points on my graph. So am I going to get to connect this one when I'm done?
No.
No. Okay? All right, so let's go ahead and we're going to draw our table here. Okay. I have x. These are all my x's. Okay, my function is -x squared. I'm going to write it slightly different from the way it looks up here. Here's why. What number is really in front of this right here? 1. I'm going to write it -1 times x squared. Okay? The reason why I'm writing it like that is to make it easier for you guys so you don't get confused about your order of operations and make a mistake and then have your whole graph turn out wrong. Okay? So this really means there's like a -1 multiplying by x squared. Okay, now, when I go to plug in my numbers, I'm going to plug in my numbers, but what operation do I have to do first? Multiply or exponents? Think about order of operations. Exponents, right? So when I plug in these numbers, I'm going to have to do this part with the exponent first. Okay? So, let's remember what it means to square a number. It means a number times itself. What's -3 times -3? Positive. So this part makes +9. Okay? Now, you still have this -1 multiplying by +9. So what is your final y value? -9. Okay? So here's your ordered pair, -3, -9. Okay, let's do the second one. We're going to use -1 because that's part of the problem, times. Now, in my spot for x, what am I putting in? -2. So think about what it means to have a -2 squared. That's -2 times -2. What's -2 times -2? +4. Okay, now I still have this +4 multiplying by -1, so that makes -4 for my final y value. Okay, next, -1 times, in my x spot, I'm putting in -1. Okay, -1 times itself. -1 times -1. +1. Now, I still have that +1 multiplying by this -1, so what does that give me? -1. Okay? Can you guys see how when we're working this, if we do it really fast, we could easily make a careless mistake and get a wrong sign here for our answer? Like, if we did this like super duper fast and we're just not really paying attention to what we're doing, it's super easy to just mix it up and get a wrong sign in our answer, right? Okay, what's -1 times 0? 0. Okay, so for this one, we get -1. And now we're going to plug in +2. That gives me +4 times a -1, -4. Do you guys see any like kind of similarity happening here? What's your guess for the next number? -9. Let's check and see. -1 times +3 squared. Well, +3 is +9, but that's multiplying by -1, so that's -9. Okay? What you're going to find, class, is when you're graphing a function with a squared on the x, you're going to find this pattern happening. I guess not really so much a pattern, but a similarity, okay? Where you have kind of like a center number, and then each of the numbers around it is the same. So it kind of like creates a mirror image. That's why when we graph this one, it's not going to make a straight line, okay? Whenever we have an x squared, when we graph, it's not going to make a straight line. It's actually going to make a shape that looks like a U. Does anyone know what that U-type shape is called? Parabola. Yeah. Now, sometimes the parabola is a right side up U. Sometimes it can be an upside down U. Okay? So let's go ahead and draw our graph so that we can see what kind this one's going to be. Okay, I'm making my graph so I have a lot of room on the bottom because I noticed all my y values are either negative or 0. So I don't really need room up above. Okay? All right, now, make sure when you're drawing a graph, and I haven't provided you one, you make the spacing even. If you don't make the spacing even, it's going to turn out funky looking. So I want to make these spaces about the same size as these ones. If I make them different sizes, my graph comes up looking all tweaked. Okay, so there's some spaces there. Okay, so now let's go ahead and graph my points. So my first one, -3, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, next, -2, -4. 1, 2, 3, 4. Now, -1, -1. -1, down 1. Okay, 0, 0. That's right here at the origin. Okay, 1, -1, so over 1, down 1. 2, -4, so over 1, 2, and down 1, 2, 3, 4. And then 3, -9, over 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right. So there are my points. If I were to connect them, I would get an upside down U, right? Okay. Do I get to connect them though?
No.
No, because it gave me a special specific domain, so I'm not going to connect them. If it said all real numbers, then I would connect. Okay? Now, here's your homework tonight, so write this down, please.
Textbook?
Okay, you're going to do textbook, page 120. Remember that book that we checked out in the beginning of the year? That's been sitting at home collecting dust somewhere? You're going to find it, and you're going to do this page and these problems. Okay, if you never checked out a textbook, you need to take your ID card to the library during lunch or after school and check one out.